Okay, folks, welcome. Welcome again to Iron Beetle, this exciting Twitch and YouTube show where we study the Target codebase, the codebase for a modern database for financial accounting, which is implemented in Zig, which doesn't allocate memory at runtime, which implements funds accounts algorithm, which assumes that this can fail and return garbage data, and many other exciting things. Okay, so yeah, where are we right now? We almost finishing the story about the request protocol, how the database maintains client sessions, how the database decides who is and who is not connected to the cluster. And the only thing we are yet to cover is like the request transmission protocol. And that's kind of like not good at all, actually. And my plan for today was to just go and code a better version of the request protocol. But right before starting, I realized that there were a couple of VOPR seeds failing, and I figured out that actually doing one more episode of live debugging through VOPR seed might be useful. So let us do just that. Let us debug like some failing seed from our deterministic simulator. Okay, and that means I actually, well, no, I don't need to seed. Okay, so what the hell is VOPR? Okay, so VOPR or CFO or DevHub, like, you know, this thing has many names, is basically this user interface which shows us the results of our the results of fuzzy target on a bunch of remote machines. And by the way, if you are curious about, and no, I don't want Zulip chat, I want the boy. If you want to learn more about this thing, I've recently gave a talk on Hydros Boy. So highly recommend checking it out. But anyway, for us, the there's some thing here is that like there's a lot of red. There are failures. We need to fix it. And first of all, we need to, like, you know, there is like a menu of failures. So this one is failing. This one is failing. This one is failing, but this is Chaitanya pull request, so that's fine. And our task is find. Our first task is to find this seed. So let's click on a particular mode of our fuzzer. So VOPR testing, which uses a simple key value state machine rather than accounting. And also, actually, let's just kill the commit, like, super hacking on the URL. And okay, yeah, now we see a bunch of failures, and I want to find one which is simple. Okay, this is it. So just 1 second to fail. Okay, let's see if this reproduces on main. Well, before this, let's actually just a minute. Let's synchronize with main. Then let's see whether we are failing or not. And if we are failing, that is going to be a success for us. We'll have something to debug. Okay, yeah, success. We failed. We failed, and now we can conveniently reproduce this in the editor. Okay, and probably I don't need this to be a release, so let's see from the comfort of our editor, where are we failing? Okay, yeah, we are failing somewhere around upgrades. So probably, and one suspicion here is that I introduced this bug when I was changing VOPR code recently. So let's see. Okay, so we are, so like, what is happening? We are stepping through the VOPR, and this is the new code I introduced, and which I suspect has to do with this failure. So what is happening here? Originally, our VOPR worked on a tick basis. So tick is a thing which measures time in target. Every 10 milliseconds, we do a tick. And I remember that throughout, 50 episodes of Iron Beetle, I was claiming that a tick in target is like almost like a game, like 15 milliseconds, in game it's 16, and I said that in target is 15. I don't know where I got that, that is completely wrong. The tick in target is 10 milliseconds. So anyway, normally we tick every 10 milliseconds. And in the simulator, in the VOPR, we use fake time, so we tick as fast as possible. But still, our cadence, our logical cadence is 10 milliseconds. And what I realized is that 10 milliseconds cadence isn't really right for VOPR at all, because most of our input-output operations, especially input-output operations which involve disk, but also even just the network, sending message over network, all those IOPS usually take way less than 10 milliseconds. So it just doesn't matter to model it that way. And I wrote this new code which says that before we do a tick, we actually make sure that we process through all of the network and storage operations. And yeah, this is a suspect bug, because you see, here we fail on some assert which relates to upgrades. And here, this is like a comment also about upgrades, which I kind of copy pasted, but didn't really understand. So okay, but maybe it's a genuine bug. Okay, let's see what is happening here. So we are executing an op, and we have upgrade release. Something wrong here. Okay, let's just print it. Upgrade release equals and duration equals. Let's see, cannot format optional. Let's specify so upgrade release is optional. Okay, let's format if 8 with a question mark. Operation. Okay, what is operation 128? So this is test and state machine. Wait, no, I want test and state machine. Okay, so who is okay, So, okay, we printed the stuff and it says that operation is 100, okay, 128, you see? And it doesn't make sense to me because I don't remember this operation, and it says that this is a reserved operation. Wait, okay, yeah, right, okay. So this is a reserved operation, so this is actually should be the first operation from the state machine. Operation. Okay, yeah. Are we actually running the testing state machine? Yep, you are running the testing machine, so this is echo. Okay, so now okay, now I think this makes sense. So basically, we are executing an operation, which is an upgrade. Like, okay, so no, we are executing an operation, which is like not an upgrade, but we have an upgrade queued. Like, we haven't really covered upgrades yet. We really should, because like upgrades are fascinating. But long story short is that we have an invariant in Tagbittle that every operation is executed by exactly one version of the binary. And if you need to upgrade a cluster, the cluster automatically coordinates which operation triggers the new version and automatically restarts in the new version for that operation. So here, this upgrade release being non-zero, and it is non-zero, means that we are preparing to do an upgrade, and yet we are executing our operation. So that is clearly not correct. Okay, so why is this happening? Okay, so we should be doing this upgrade thing here. So what is replicas? So I wonder all of storage steps, since upgrades occur at checkpoint completion. And could checkpoint completion be triggered by some network request, I'm wondering. I don't know. Okay, so what are upgrades? Replica upgrades is okay. Replica upgrades. Who modifies replica upgrades? So replica upgrades should store, like, the plan for replica to upgrade, and yeah, so replica release execute soon is what execute soon is what we pass as a callback to our replica. Okay, so let's then print this out to see when we are going to then current stack trace. Yeah, let's see who triggers the release and why that happens. Okay, so this is where we fail, and this is where we execute the release, and that happens. Okay. So far, it looks like it actually should work because, okay, we first... I hate when it happens. Is there like... Why there isn't useful backtrace there? Okay, upgrade. Upgrade is optional release. Okay, so then this should be a question mark. Okay, so many nulls. Okay, so we say we will soon execute a release, and then we hit this in the storage. So before upgrade. So let's actually before after. Let's print this before and after, and see who modifies the memory. And yeah, this is kind of like caveman level printf debugging. Like I wish there was like a debugger which just worked for native code, but ever since started working with Java, I haven't seen a debugger which I could use as a REPL. And if I cannot use debugger as a REPL, I kind of like don't really want using it. Okay. Okay, no, I don't understand control flow here. Let's see, we print that, hey, we are going to execute the release, and that goes from here. So after we say that we are going to release execute soon, Oh, it might actually, okay, it might actually be the same iteration. Okay, let's take a closer look there then. So you see, we say that, hey, we are going to release execute soon. And that is like release transition. But then for some reason, we actually still managed to do this. Okay. So okay, so yeah, okay, so this right now feels like it might actually be a genuine bug in our simulator. So this is what I understand from the overall picture. Yeah. So this is the key function. Like in production code, whenever it calls release transition, it immediately restarts. So this function technically is like no return. But in the VOPR, we cannot actually make this function return. It has to return. So the way this works in the VOPR is that instead of immediately like executing the new release, we just mark that, hey, we want to upgrade this replica. And please, once the control flow reaches back to the VOPR, trigger this release execute thing. But the control flow actually doesn't reach the VOPR because there is already a bunch of callbacks scheduled at the storage level. So here, like this step actually manages to execute quite a bit of things. Okay, so in the VOPR, we actually need to be able to break in the middle here, especially like yeah. So like this is this like while loop, and we need to say like, hey, let's not do this. Let's not do this anymore. What would be a nice way to do this? Because I kind of like don't want just so I probably should explain what the step function does. So again, this is like this again goes back to the idea that like we logically take 10 milliseconds, but in the VOPR we want to model I/O which happens faster than a single tick. So when we submit an I/O, we calculate a tick where it should finish. And for very fast I/O, that tick is actually current tick. So in the step function, we take all the IOPS which are from the current tick and execute them in random order. And we can change this function to execute a random one instead of like all of the random ones, but that is kind of like messy, because I kind of like how we just fetch at most 32 into a slice and then shuffle those slices and then execute them in random order. I'm actually okay. I'm curious. Was this actually possible before my changes? So let me reset this and go back to main and see. Okay, this isn't. Okay, let's. Okay, this actually this is the problematic. So let's go before that. Let's go to this one. Okay, so here we say storage.tick, and ZLS still cannot properly react to file changes. Okay, yeah. I think it is. It does sound like a genuine pre-existing bug in the VOPR, because you see, like, this is like the same essential structure that we can we are executing a bunch of callbacks, and we might not actually finish it. Okay. Okay. Okay, I think I can do something hacky here. I think I can say that. Okay. So basically, what hits us is next tick, I believe. So if we just have if we just break out of the step before next tick, then it should be fine. So that we don't do. Yeah, so this is next tick. So basically, we say if read count equals 0 and write count equals 0, only then we process next tick. And that should fix the issue, because I mean, it is correct for us not to process next tick, because we are going to return true here, and in the cluster, this whole thing runs in a loop. Okay, so let's see if that fixes the thing. No, it doesn't. Okay, which is super weird, because okay, Okay. Yeah. Right now, I'm trying to see if this execute soon is also triggered by the next tick, because if it is the case, then we need to hmm. Okay. Well, no. I don't get this because, okay, so we are here. So we don't get out of here. So we do break out of this loop, and we should be calling release execute before we get into next tick. Okay, so let's see. Let's see. Returning from step. We're running next tick. Concurrency is fine. Concurrency is always fine. Okay, so we do this. Which is oh dear. Those are mutable. Those are mutable. That's why they're 0. Okay. So let's do this. If what okay, let's do simple things. If read count greater than 0 or write count greater than 0, then we do this. If our storage queue is not empty, then we do this and we return true. Otherwise, we return false. Okay, so this one, I think, should pass visit. Yes, okay. Okay, I don't really love this fix, but okay, let's do this. I think this is fine. Famous last words. Okay. So let's do this. And then we or only next step here. This is to get cluster. The cluster. This is to this way. Clusters code can execute between IO and next tick. Okay. Okay. In the simulator, we do not process next queue. Next queue if we processed any IO. This is to get the simulator the chance to start the corresponding replica into a newer version. Okay. I think this should do it. So now let's write a nice commit message. Fix false positive. What is our command? We use the git tags. It's not tags. Like basically, actually, Git has like this first class feature where you can add meter information in the commit message by saying like something colon and something. So it's not like plain text thing. It actually is like first class Git annotation, which we don't use, but still nice. Okay. Okay. Fixes VOPR seed using crash during upgrade. I believe this is existing VOPR bug, which was uncovered by the zero tick, by the tickless VOPR, and now would be cool to actually find that pull request. Okay. No, I actually want to. Yes, this is it. From in production release execute is no return function that immediately executes into the new version. In VOPR, release execute just sets flag. VOPR acts on flag when it gets control. Before storage tick and after storage step, execute it IO, IOPS, and next tick queue callbacks after each other. So it was possibility that IO and IOP triggers this execute and next tick steps into it, but it wasn't it before. To fix it, ensure that storage step yields before yields between IOPS and next ticks. This is still perhaps not ideal, as we should be yielding after every individual IOP. Yep. But let's see if this is enough to get the thing fixed. I think we should have a next tick somewhere in commit loop to make sure that the build does happen. Okay, sounds like pretty decent commit message to me. So we can now. Oh, sorry, but there's like 4 parrots simultaneously right outside of my window, sitting on the electric cable. That is too cute. Okay, 2 of them left. I can get back to coding probably. I'm as distracted as I can. Okay. See. Glad. VOPR false positive. Okay. Let's create a pull request. Let's double check that it looks reasonable and assign a reviewer. One thing we do at Targetbittle is that we proactively select a reviewer for the pull request, just so that, like, you have at least 2 people whose job is to get the code into the main branch. Okay, so yeah, it was actually pretty fast C to debug. So now let's finally talk about what I was going to talk about today, and that is request protocol. And this is a problem. So if we open our client, we'll see the logic for retransmitting a request. So normally a client sends a request to the cluster, and at some point later it receives a response. If it doesn't receive a response, the client goes and retransmits the request. And you see the logic here is pretty reasonable. The first time we obviously submitted a request to the cluster, to the primary, because the primary is the node through which all of the requests are flying. But if we weren't successful, then perhaps primary is down or primary is unreachable. So let's do the logical thing. Let's toss the request to the next replica in the ring. So we like round robin through our entire cluster of 6 replicas. And this is like very reasonable. But if you look at what happens on the opposite side of the spectrum, so replica on request, there is like a lot of logic here. So let's see. If we are primary, then we process requests normally and the client gets its response. Everything's all right. But if the client does this transmit request to a new node, then we hit this case, ignore message backup. And if this actually was a message for the view we are currently in, then we just drop the message on the floor. And that's problematic. So imagine what happens if, like, okay, the logic seems all right if the reason why the client didn't get a response was that the cluster did a view change. So let's say that replica number 3 was a primary and the client was sending request 3 and everything was fine, and then, like, 3 crashed. And then the cluster does a view change and 4 becomes the new primary. And what happens in that case is that the client doesn't know about the view change, so it still thinks that 3 is a primary, so but it sees that its request was not processed. So it retransmits it, and it retransmits it to the next replica in the ring, which is replica number 4, because we don't do raft, we do VSR of deterministic round robin for leadership. So anyway, it retransmits it to 4. 4 is now a primary, it gets a request, everything's fine. But now, let's imagine a situation where the reason for absence of a reply is not that the primary is actually down, but just the fact that a single message got lost, or maybe it is delayed. It takes like a long time process. So in this case, the client sends retransmits the request to 4, but 4 is backup, and it just drops message on the floor. And then the timeout fires on the client again, and it sends to the next replica in the ring, so to the 5, and then to the 0, and then to the 1, and only then to the 2, and then to the 3 again. So, like, to do an actual retry against the primary, the client needs to go through the entire cluster, and it sends this 1 megabyte to prepare to like every replica. This is just outright performance bugs, and I was planning on fixing it today, but well, we got into fixing a VOPR seed instead, which hopefully was at least somewhat entertaining. But that means that the next time, hopefully, we'll start right with this new protocol for requests. Okay, folks, that's it for today. Thanks for joining. And if you missed this, you know that you can find the recording on YouTube. And if you didn't miss this, then you know that in exactly 1 week minus 1 hour at 5 p.m. UTC, you can join again live on Twitch. Thank you, and see you in a week.